Good evening. This is the homework number 2 for the course Advanced Embedded. So we will do the cucumber board in 4 tasks. The first one, we will set up the enable watchdog timer, and the second, we will use the two interrupt. The first one is the push button interrupt, and the second is the timer interrupt. For turn off the LED after 2 seconds. And the third is we will measure the temperature from the BMP 2S0 and the HTS221 sensor. This is the built-in sensor on the Cucumber board. And the fourth task, we will send the measure temperature to the web server. So first thing, we have to take a look at the peripheral and the GPIO pin mapped. We will see that the push button here will connect to the GPIO 0 and the built-in LED will connect to the GPIO 2. And also the built-in sensor from the BMP 2S0 and the HTS221 will connect to the I2C with the address 0x5F, 5F, and also the BMP 2S0 will connect to the I2C address at 0x76. So we have to confirm this one first by using the scanning IC square. This one I will use this port to scan the IC, the I2C and the board information. So this one we will take a look the information here. If the built-in sensor on the board is working correctly, the scanning of the I2C should be shown on this value. So I will build this one to the Cucumber. Now I connect the Cucumber to my laptop already. So we will check the I2C first, waiting them to compile. This one you can search on the Google. There are a lot of the example for the I2C searching. So we will use this one with the Cucumber board. Okay, there are some errors. So I will disconnect it and then try again. Okay, it's worked now. We are waiting them to upload. So I will explain for the this one for the instruction 1 and the second instruction first, so we can see for more easily if I separate the code into another file. This one is the first and the second that we will set up the watchdog for the 5 second, and after the 5 second the watchdog will reset the cucumber board. And also for the second talk, we will have the timer interrupt and also the push button interrupt, that when we push the button, the LED will be toggled. In this case, if the LED is off, it will on, and then after on, we will configure the timer with the P scale for the 80 megahertz divided by 80. So we will have 1 million microsecond. So we will delay it for 2 seconds. We have to put 2 million. And then the LED will be on for 2 seconds. After that, the timer interrupt will be occur by send to this one. The timer interrupt ISR 0. The LED will be toggled again. If it is on, it will be off. And then after off, we will set the timer to be 0. So it will reset itself in this one. And here for the setup, I will put the reset by watchdog timer. It will show reset by watchdog timer at the first time. And also if we go to here for the main loop, now I put the delay for 2 seconds. So that means if the code is working completely within 5 seconds, because now we have only 2 seconds, that means the watchdog will not operate. But if I delay for 5 seconds or 6 seconds, the watchdog will be operated to reset the cucumber board. So this one is the example of the code. I will show you the result later. Let's back to the I square C. We will go to the serial monitor. Okay, now we will see this one. There is only the zero x 68. That is the I square C from the MPU 6050, and also the 0x76 is from the BMP 2A0, but the system cannot see the HS3221 at the 0x5F, so that means there are some issue on this sensor. So for this homework, we will measure the temperature on the BMP 2A0 instead. Okay. So we will finish this one for the I2C scanning. We will use this one to measure the temperature. So let's start at the watchdog and the button and the timer interrupt. So I will open the delay here to be complete the task within 2 seconds. Then I will build. Okay. We will see the first and the second task first. After that, I will go to the third and the fourth task by combining the first and the two and the second task together with the code. We will go to the serial monitor. So we will see here the system is work perfectly because the watchdog is not operated because we have set the delay for only 2 seconds. But we have declared this one, the timeout is 5 seconds. So if we try another, let's change to 6. Okay, then we will do it later. So let me show you for the push button interrupt and the reset, the timer interrupt. First, I will show you on the okay. You will see now I press the button here. The yellow LED will be turn on for 2 seconds, and after that the interrupt timer will be interrupted by turn off the LED and then configure the timer to be 0. I will press it again. Okay. Now I have shown you already for the push button interrupt and then send the configuration to the interrupt timer for 2 seconds. And then if you toggle the LED to turn off and then set the timer to be 0. After that, we will see how to operate the watchdog. Now we set the watchdog for 5 seconds. So I have delayed for 6 seconds. That means it will reset by the watchdog. Okay, now we have delayed for 6 seconds. So we will see it. The watchdog will continue reset the timer because I have delay for 6 seconds. So it will always reset the system every 6 seconds. We will see here. Okay, so we finish at the talk, at the first talk and the second talk. So let's continue on the third and the fourth by measure the temperature from the BMP to S0 and HTS221. But at the first that I show you, we have using the scanner from the I2C, we cannot detect the address of this one. So we will measure the temperature from this IC first for every 6 seconds, and then I will show you the average temperature with the timestamp, the NTP timestamp for every minute for the 24 hour. And then we will upload the value to the web server and we can search on hour and the minute to find the temperature value. Let's go to the hour code. So now I have already copied the timer and the watchdog of the first file that I show you to put in this one already. And then this one is my Wi-Fi SSID and the password. And also this one is the library. The library I use from the Adafruit, but I did not use the uh, parentheses. For the heading file, I have to use this one because my computer cannot search the header on the Arduino library. So I have to copy all this one, the header, into the directory. Because I have saved the main file here, I have to copy the header file and the CPP file to the directory of the main file of my code. So I will use this one, this sample, instead of using the parentheses. So let's start. We will create this one and also the structure to keep the temperature value and the sum of the temperature. And then I will use the code from the first homework by getting time from the NTP server and use the offset from the GTM past 7 from the Thailand time past 7 of the UTC time past 7 hour. So it will be 7 multiplied by 300, 3000 and 600 seconds. And this one I will create the structure and the preview to count for every 6 seconds and for every 60 seconds. And also another constant value that will help us to count the value for 6 seconds and to calculate the number of the loop. Here we will set up the server first, and then this one is the same code for the first task and the second task. I copy this one to already for the timer and the push button interrupt. And then we will go to the setup. Setup here it will the same with the first and the second task. So we will go to here. First thing, I will connect to the BMP to S0 first by I2C with the address 0x76. So I declare this one. And here I also try to connect the HTS221, but we don't have to put the address here in the blanket because we have the address in the header file already. So if we call this one, the code will be read the address in the header file instead. So after we connect to the board sensor, then I will connect to the my Wi-Fi home. That is the first code that I copy from the first homework. And then after that, I will configure the time by receiving the time from the NTP server. With the NTP server, I will also use the local time here. We will get the NTP server times and then put it in the string with the day, month, years, and also time in hour and second, minute, and also we will stamp the time. Let's see. After that, we will go to the main loop. So I will use this one to count for every 6 seconds. That means I will use the mil. The mil is the internal counter of the cucumber board. It will count to infinity value and it will be reset. If we reset the cucumber board, that means I set the p mil for 0 first. If the mil is count to 6,000, that means this one will be true. That means we can read the value for every 6 seconds. If it will be true, it will operate this one to read the temperature and the pressure. But this one we will read only the temperature and show you only the temperature value. So we will keep it, read the value for every 6 seconds, and then we will keep it at the AVG temp PMB, this one at the array 1, at the array 0. And after that, it will pass the index to be 1 because 0 plus 1 will be 1 to count again for the another 6 seconds. This one will be changed to 6,000. But after that, this one will count to 12,000. That means 12,000 minus 6,000. It will be more than 6,000. It will operate again by read the temperature and then keep it as the array 1 with the index 1 and then we will update the index again to be the second index. And then after that, I will count again because we have to use the average value to show on the web server. So here I will put it for 50, 60 seconds. So it will be 60,000 milliseconds in the Arduino. So if it count for more than 60 seconds, then I will check the local time and then I will use the for loop to sum up with update the index of the average temp, sum up again and pass with the every temps, and then I will update here for 10 value. After 10 value, I will divide by once. One is the number is the 10. So we will have the average temperature for the 10 value. 10 value of the temperature uh, divide by 10. So we will got the temperature average for 1 minute. And then after that, I will set once this one is mean the index to be 0 again to use in this one to set at the 0. So it will help us to reduce a lot of the space. We don't have to store the value, the temp value for 6 seconds, but we have store value for every 1 minute instead before updating to the web server. And then after that, I will connect to this one, the client. And also this one is is the HTML code that we can search on the example, like the heading file and some search engine that we can use it. It look like the plugin. We can use it for the searching some value, and also we can create the space, and then you can some heading file, and also adjust some space and the color of the table. So we will update this one for every 1 minute. It will update the value of the temperature to the web server. Okay, and then we will see here the delay. I will give the delay only. Oh no, I will not open this one because we have the watchdog reset here, and then I have already declared here for 5 seconds. If the total code is working more than 5 seconds, the Cucumber bot will be reset by the watchdog. So we will see the result. After is the measure the value. I will upload. We are waiting it to reset. Okay, I will show you the. Yeah. Now you will see that the system is working perfectly because the main loop is working complete within 5 seconds. So that means the watchdog will not reset the system. and then I will show you let me okay, after I press the button here, yeah, you will see the yellow, the orange LED will be turned on for 2 seconds by push button interrupt, and then reset or turn off by the timer interrupt. 1, 2. Okay, this one is the second task. Okay, let's see on the temperature. After that, we have to go to the serial monitor. Okay, we have to wait for 1 minute. This web server will show you the temperature value. Okay, the first value is count, so we will wait for the second, for the another minute. Because I do this due to we have to save the storage space on the cucumber. We don't need to uh, keep the value for every 6 seconds for infinity. So after we'll do the average value every 1 minute and then record to the cucumber. The temperature value that we measure for 6 seconds will be reset itself by the index of the array will be pointed to at the 0, and then another value will be recorded at the array index 0, and then the new 6 seconds will be recorded at the array index 1, and the another will be recorded at the array index 3 up to 10 value. So after 10 value, we will sum up the temperature of the 10 value and then divide by 10. We will have the average value for the minute, and then it will reset again. So we can save a lot of the storage space by doing this one. Okay, now we got the three value already. So I try to search. Let's try. See here, we put the hour and then 52. So that means we can search any, let's see, hour and then minute. 23 here. So it's easily for us to use the plugin. This one is the plugin. So we can copy from a lot of the example. This one is the plugin. Yeah, sorry, this one. The Google Apis. This one is like the tool for search engine. So you can use it for the plugin to search any parameter. And now we have about 4. So if you leave the Cucumber board to turn on for like 1 day, it will show us the value for every minute to cover 1 day. But we have to connect the Wi-Fi. We have to keep the Wi-Fi is connected. If we lose the Wi-Fi, that means the value will be reset. So I will upload the code again because now it's learning. So my internet connection is